Alright, this is a demonstration of a Windows root domain running on top of Micro-V. And there's a few things to understand here. The first is that this is just a plain Windows 10 install that has been lifted into a VM by Micro-V prior to boot. So everything that we see here is actually running in a VM. It has an EPT, that sort of thing. Another thing to note is that there is no networking, and the reason is Micro-V has hidden each network device from Windows. There's two network devices on this machine. Both of them are hidden because they're going to be passed through to a driver domain that we're going to be running in a second. And the driver domain is called the network device domain, or NDVM. And the purpose of that is to isolate the network and to provide a backend for other VMs that are running on the system, including Windows. So in a second, we're going to be launching the network front end in Windows, which will connect to the back end in the driver domain. All right, so before we do that, we'll look at Device Manager and look at a few devices. First thing to note is that there are two instances of the Visor driver, one for each physical network device, and the purpose of these drivers is to relay interrupts received by Windows to the driver domain. And then we have the VM Builder, and that is responsible for building the initial DOM0 that is run in user space that we're going to see in a second. And then the last one to look at is the PV bus driver. So the PV bus is used to provide PV networking and PV disk access in Windows, and it has been enumerated and loaded because it thinks that it is running on Xen. Actually, it's running on Micro-V, and Micro-V has implemented a portion of the Xen PV interface in order for PV networking and disk to actually work. All right, so now we can start up the guest VMs. So we see the typical boot messages from Linux flowing by, and we hear device attaches from Windows. And now we can log in. So what we're looking at is a Xen DOM0 from the perspective of the Xen PV interface. So this VM contains your typical XL tool stack and can create further DOM-Us. And we can look at this from the Windows perspective in Task Manager. Let me rearrange. So in Task Manager, we can see this UVCTL process. And that's what this is here. We're actually looking at the console of UVCTL. And what UVCTL is responsible for is it's really a donation mechanism. It donates its runtime given to it by the Windows scheduler to these VMs. And so that is how the VMs running in this window actually receive runtime, is from a donation from this process. And another thing to note is that even though this VM is running what looks like a Windows process, the actual memory of the VM is not accessible in Windows. So it's actually, the hypervisor has actually unmapped the VM's RAM from the root domain's EPT. So it can't actually see any of the contents of the VM. So there's isolation there. Okay, so then this process here had some systemd scripts that actually kicked off another VM, and we can look at that Excel list. So we'll see here DOM0, that's the VM that we're interacting with right now. And then we see in DVM, and that's the driver domain. That's the thing that's actually providing a network backend that we're going to use in a second. And then this last entry is the root VM. And this is really just a placeholder for the Windows domain. And this is a little misleading. This vCPU count is not accurate. There's actually 8 cores on this CPU, on this machine. And the reason this is inaccurate is because basically the VM, by the time XenStore is running in this DOM0, this root VM really already exists, right? Because it's Windows. And so this basically this is just a placeholder so that PV interfaces can interact eventually, that we're going to use in a second. And so there's a special path that was added in Excel Create specifically, to basically create a shell of a VM. So the domain isn't really constructed, right, in terms of memory. Memory isn't allocated because it already has memory. So it's basically just XenStore nodes that are filled out. And the number of vCPUs really is sort of inconsequential at that point. Okay, so we have these VMs. Now we can actually turn on networking in Windows. So to do that, we can do network connections. And we'll see 2 interfaces. So the management interface is so that Windows can communicate with DOM0. Right, so these 2 VMs can communicate with another. It's just a local network. And then the demo interface is actually what talks to the backend in the NDVM, and that's how we actually get internet access. We'll go ahead and enable this. And we have networking, hooray. So now we can run a speed test, just for fun. Airbox broadband, okay, go. Alright, so 150 down, 50 up. That's right under native speeds for my connection here. So that's great. Go ahead and close that. And so that sums it up. If you'd like to learn more or even play with the code, I will include the link in the video description. Otherwise, thank you for watching.